Hi, good afternoon, everybody, and thanks, Krishna, Arindam, and Shesha for coming here and taking time to talk to the audience here. So quickly, before I ask the questions, just a quick show of hands on awareness of quantum in this room. How many of you are familiar with qubits? All right. Familiarity with quantum entanglement. See? And Grover and Shor's algorithm, how many of you are familiar with it? Cool, 2. So I think you got so I think we have a good set of answers that we can educate the audience about. So I'll just first start by saying, quantum seems like science fiction to me, right? You change something here, even if the photon that is entangled is in moon, it will show some effect. So that to me is pure science fiction. So what has transpired in the last 5 years to kind of say this is not science fiction, but this is reality? Start with Arindam and, we'll go through the other panelists.
Can you hear me? Yeah. Right. So I took a few notes, Naga, when you said that. And as far as quantum is concerned, over the last 5 years, the more technical details can come from the other panelists. I think, to me, there are 3 major points which has happened. First is that we started realizing that if someone makes a quantum-based device and you don't, then the other person is at serious advantage. As a result, it's going to be driven by strategic sectors. So whether or not the government, a particular country wants or not, they will be forced to develop quantum. Also, it's a realization that, that there are technologies which will be benefited by quantum, even if it is not quantum in itself. New materials coming in, new kinds of memories coming in. So they will probably, give manufacturing boost in semiconductors, memories, computing, even classical computing. So there are areas which essentially goes much beyond quantum, which will start from quantum. So this is inevitable. The quantum is going to come in the future. I think quantum computing, which the way we understand today, will come a little later. But other technologies of quantum, like quantum sensing and communication, they will come sooner. And that is what we have realized, and we are investing in that direction.
Cool. So Krishna, your thoughts on this? You've been tracking this very closely and you're doing a startup in this space.
So I should actually, I think, make this a little bit more personal as to why I'm on this stage. So Naganand mentioned last 5 years. So give or take, let's say 2020. Compared to when I started looking at this field, it was just around 2020. And I was an academic in the US. And 2 years ago, I formally retired from my lifetime job called tenure to do the startup company Accelequant. So in a sense, that should indirectly point out the momentum I sensed, where I literally put my money where my mouth is. And I'm now fully entrenched in this game. Now, to Arindam's point, the reason why people feel quantum computing is a bit out there, definitely not science fiction. Because tomorrow morning, if you wake up, there'll be any number of web portals through which, with the right connection, as an internet connection and an account, you can run a quantum program on a variety of machines. And one of the leading providers is sitting to my right, so he should comment on that in a second. But the quantum infrastructure for computing exists. The question on the table is, what do you do with it? Correct? So the issue is for all the people in this entire organization and this meeting, it's about creating value from a commercial perspective. And so to sharpen Naganand's question potentially, and that's probably question number 2, so I'll stop here and not preempt the next question. It's real. You can run quantum programs now. And maybe in response to the second question, I'll comment about how large and how commercially meaningful it will be, and to the extent we can gaze in the crystal ball when.
So I'll sort of give an industry perspective. In IBM, In fact, I'll take it 8 years back when IBM put the machine on cloud first. So that was a very small device which was very noisy. And if you look at the journey from there till today, we've been doubling the count of qubit. We've been adding that. It was 4 qubit or 5 qubit then. Now we have 156 qubit machine. We have demonstrated 1000 qubit plus already. What is interesting is how things have evolved broadly in this quantum computing space is that now we are getting to a point where some interesting computations can be done using quantum computing. Last year, a paper was published, part of IBM and Lawrence Livermore Laboratory collaboration to run a particular abstract physical system on quantum hardware, simulate that system on quantum hardware. And that was a non-trivial thing, and that was benchmarked. The solution was benchmarked against the best that you could do with our classical neural network solution. It was interesting because not so much that you get results from quantum hardware that the best classical solution at that point could not emulate. What is interesting is subsequently new algorithms were innovated in classical to say we could emulate what quantum was doing. What has happened now, if you look at it, is at the cutting edge of quantum computing, the reference has flipped. Now the reference is quantum. Now the classical needs to innovate if it has to meet quantum. Earlier, when we were very smaller machines, you had the actual exact solution available. Quantum would benchmark against the exact solution and say how good or close we are. Since that publication, what has happened is the actor's persona has flipped at the cutting edge.
Understood.
So what then happens is, as the generation evolves, quantum generates certain results that classical cannot do, but it doesn't mean that classical will never do. New innovative algorithms could come, new heuristic could come to demonstrate that.
Understood.
So that flips the argument.
Correct. But to my understanding, not all classical algorithms can be, it's very fruitful to run on a quantum computing, right? Because there are certain classes of algorithms that run better on a quantum as opposed to classical. But even otherwise, currently we are still in the proof points to say that quantum algorithms or quantum computing can overtake the classical computing because of the qubit limitation, right? So in what applications we think, because we have seen many technologies evolve in life. We had blockchain. It was considered it was going to change the world, but it couldn't find application. It was technology that didn't find any application. So in quantum computing, even if you get the hardware, assume we are going to solve the problem of hardware, what kind of algorithms or applications we think we can show running in the next 5 years to say quantum computing is for real? Yeah.
Shall I take that?
You want to take it? Yeah.
Okay. So because we are an early stage startup, that's exactly what we do. So with the current qubits available in the market, as in through the internet, the cloud, the two areas which are kind of extreme, and there are others in between where we are focusing on, broadly the class of problems called optimization, which in the commercial setting relate to supply chain management. And, so if you folks are in this business community, there is an acronym called TAM, Total Accessible Market. And this particular area has a TAM anywhere between $12 to $15 billion. And so that's a healthy amount of TAM. What do you want to solve in this? You would like to solve an optimum, find an optimum solution. So two classic problems which are constantly being improved are things called crew scheduling and network planning. Just to give you an idea, network planning is which plane model is worth sitting in which airport overnight and what route should it take tomorrow so that the number of empty seats is minimized but you don't overbook. And the second is crew scheduling. A 777 pilot and crew cannot fly a 737. So they have to be in the right city at the right time, and that's surprisingly, that's a multi-billion-dollar market. This optimization problem has scale. how many airports can you deal with, how many pilots can you deal with, and how many planes can you deal with. So in talking to customers who actually, our customers who actually sell this software to make their own revenue, it turns out that there are choke points. We won't go into the numbers now. If they could solve larger, you get a better global solution, save them money, and classical stops at a certain point. And so crossing that certain point, that choke point, and being able to solve a problem much larger than what can be done in a reasonable amount of time. So the other example of this would be, suppose you took 5 days to solve a problem, to schedule planes. Your data is stale. You're solving an old problem based on what you knew 5 days ago. If you could solve it in 18 hours, it's actionable the same day for tomorrow. So time scales are also to be thought through carefully, where faster, people say it's 1 million or 1 billion times faster. Quite often to be commercially relevant, you don't need it to be 1 billion or 1 billion times faster. Okay. And so that's one extreme. The other extreme is machine learning training. And people are now talking about the amount of electricity it takes, but it's a humongous, costly effort to train any of these models.
Yeah, there's a data that says you're going to use 8% of the world's electricity in data
Correct.
centers.
And cutting down on the training time using a quantum support. And the last comment I'll make, and then I'll stop and yield to my colleagues here, is people think of a quantum computer as working in isolation, like your laptop. Usually it works in tandem with a ring of classical computers in something like a hybrid data center. So there's some exchange going on with the classical and the quantum. It's not quantum by itself. And that, I think, is the way these systems are going to look. And there are already hybrid data centers popping up in the world. So they exist now. It's not even 5 years from now.
Arindam, you
Right. So, thanks. I think Krishna covered the computing domain. In terms of the application and coming to market, I think the quantum sensing will come first, which means there are huge number of applications in the health sector, in communications, in aviation, in various other civic sectors where we will have devices which will do things in a completely different way. For example, the MRI machines, whether tomorrow we will have handheld MRI machines, we don't have to go inside the magnet anymore. Whether we have much better sensors which are there all over the place, whether it's in your car or your mobile or anywhere else. So what I would see that more innovation in the quantum space coming in the application of sensors, and that also is driving the materials and devices sector. What I mean by this is that if you look at the way the projection of the market value is being changed every year, from 2023 to 2024, the market presence of sensing, quantum sensing domain has been renormalized by 6 times. From about 6 billion by 2040, it's coming to about 36 billion by 2040. And as and when we get better devices and quantum inspired or quantum enabled devices, probably this number is going to go up even more. The quantum computing is still at the highest in terms of the projected value of $2 trillion by 2040. But other sectors are coming up really fast. I'm quite sure once we get semiconducting foundries in India, we will make these manufacturing of these devices, and that value will get renormalized even faster.
Lovely. So I know IBM is, and other competitors of IBM. I don't want to monopolize IBM here, although you're from IBM. So in terms of computing, Arindam mentioned about sensing. What do you see happening in terms of applications for computing? Because Krishna mentioned a few. Where are you seeing action now?
So in the near term, if you see, we have working groups on 4 themes that IBM is driving with wider community. This is not IBM internal, but it's a community engagement. One is healthcare life sciences, one is on materials, one is on high energy physics, and fourth is optimization. Now these are broad thematic areas. Naturally, individual problems will be individual vectors within that thematic area, but you got to sort of get a sense that these areas have high computational needs, and these areas have problems that require significant computing budget. So these are likely candidates for quantum computing to add value, where they solve some, less likely that they're going to solve the whole stack, but some key kernel of the stack in quantum, and therefore add value, which is the complicated part. Typically, quantum could add value in two ways. One is obviously the execution time, which is everybody worries, cares about. It could also be quality of results. As simple as the machine learning, for example, in healthcare life sciences, if you move the needle a little bit in healthcare life sciences, that means it's a real impact on real people. Their quality becomes important. It's not always about execution, though execution is the key value proposition. Quality is also just as equal. One quick note is that in the steady state, eventually, where this is all leading, is you're going to have data center which has CPUs, you have GPUs which is already there, you're going to have QPUs which are quantum processing units in the mix. And your compute needs is going to be satisfied by all these three in combination, which is what we sometimes call quantum-centric supercomputing or quantum-enabled supercomputing. And typically, these are the class of problems that has significant compute needs and which anyway go to a on-prem or a data center to solve, or a HPC stack to solve. That's where it's likely to reside, and you're going to use that to solve these problems.
And that paradigm is already emerging, right? I mean,
that paradigm is already emerging. We just had a data center in Germany now. 2 more machines were added in one Fraunhofer area. So slowly you are seeing, at least in the OECD countries, people buying these machines and deploying it in data centers.
Got it. So I'll combine the next 2 questions that is targeted more towards India. Where is India in terms of the quantum hierarchy in the world? And Arindam, you mentioned sensing is where we'll make a difference, and Krishna, you said algorithms. So where are we in that quantum hierarchy, and then where will we see more action in India in the next 3 to 5 years?
Okay, I think India is investing in all of them. It's not just computing or sensing. I think the National Quantum Mission. The National Quantum Mission started with 6,000 crore of kitty, and it's equally distributing between computing, sensing, communication, and materials. I think what India is parallelly trying to do is to promote the startup ecosystem in all 4 directions. For example, recently there was a separate startup call, and 104 startups actually responded to build the various quantum-related products, both in software and hardware. India is extremely interested, and with collaborations like IBM and others, to develop hardware and hybrid technologies with quantum classical interface. I would also add one more thing. Karnataka government is extremely, I would say, advanced in supporting quantum in Karnataka.
We always are.
Yeah, absolutely. So they have already started this quantum research park, and there are new Bangalore Quantum Summit coming up in 6 months down the line. It's very exciting time, the way India is becoming very,
Krishna, your thoughts?
Just a small qualifier. We are actually a US-based startup company with a technology team being in India. So it's an Indian subsidiary. And the area that we are personally focused on, which is all happening in India right now, in the subsidiary, is to take a class of applications that are motivated by revenue and try to deploy them at a large scale, larger than what you could do without us, sooner. So we personally think that you could see commercial grade solutions with interest from potential deep-pocketed customers as early as 2 years from now. So that's the vision we have for ourselves. And I don't want to speak to Shesha's own company's view, but they also have characterized this nicely from what I've seen for the public domain as currently being at what is called utility scale, what's useful, and then scaling. We are a little bit, to the extent that any of us can gaze in the crystal ball, we're a little bit more bullish in thinking that that could be as early as 2 to 3 years from now.
Cool. Shesha, quick thing, because running out of time, I have one more question. So,
I think from India, I think there is still a lot of catching up to do. I think it's important that we take our strategy and actionize it. We need to move. There is significant amount of skill in the ecosystem and the community. and we should leverage that. This community is a good example of it. There is a lot of opportunity to be had, and also it is very important for us to take the opportunity, speaking particularly for the software thing, because in my interaction I engage with software companies such as Accelequant. It's important that we maintain the leadership in the software sector. If we do not get into that space and gain the right expertise and the right technologies that develop here and have that skill in all these companies that form the IT sector in a broader sense, that solution may go somewhere else. And once you have some part of the solution go somewhere else, and that too a high-end value side of the skill going somewhere else, then it's very hard to get it back.
Understood. Yeah. So last quick fire question, just two things. Wish list. Next 5 years, what do you want to see happen in quantum?
Okay. Shall I?
Yeah, please go ahead.
Okay, very quickly, I have got 3 wish lists.
Yeah.
Three items. First is the coordination. India has been, in general, a very isolated systems, academics and entrepreneurial as well as corporate sectors. Quantum is a perfect enabler in which all 3 systems can come together and create a sector together. This has been the case elsewhere, but I think one of the important things about quantum is that the final technology is not settled yet. It needs continuous feedback from the corporate to go back to the researchers will feedback. So this entanglement is required
I like that word.
in the Indian system. The second point is, I hope big Indian companies see business in quantum. Everywhere else in the world, it is the IBMs, it is the Googles, it's the Microsoft that is driving quantum. We need to have very large companies in India to find business in the 10 years down the line, where will they seriously make money. Final point is the government needs to step up as well in relaxing some of the red tapes, and it's already doing. The government is now allowing recruitment at the corporate scale because it understands that quantum is, after all, a technology which requires a very, very sophisticated skill set. And you do not have those people unless you pay them properly. I think government is stepping up.
Krishna, yours?
Yeah, so I think we're out of time. Just a quick single wish. A recognition among decision makers in the corporate world that the horizon to deployment of profitable, let's call them applications, is much sooner than you think. That recognition, I think, is really not there, and this is global. It's not just restricted to India or any other geographical region.
Thanks. Shesha?
I'd like to see more adoption. I'd like to see more startups emerge. I'd like to see more entrepreneurs and investors invest more money into this space. And I would like to see the larger companies also invest in this particular space because this is of very deep importance. Now, this is a fundamentally new compute model, and we need to master that as a larger thing for us to unlock that potentially $1 trillion, whatever that thing eventually will get to. We need to have a significant share of that pie, and that can happen only if you get into the space when it's on the greener side. And I also want to see communities like nasscom influence the policy makers in pushing this agenda. I do want to call out the paper that nasscom did a couple of years back with Avasant on quantum computing, quantum technologies in general. That was very useful. I think more such thing needs to happen. Community needs to be aware, and policy also needs to see that we can invest both on the hardware and the software, and it can go in parallel. We can walk and chew. We don't need to choose.
Thank you.
That needs to happen.
Lovely. I hope in 25 minutes we proved to everybody that quantum is for real, and all of you are excited to go spend some more time on quantum. With that, thanks a lot for all 3 of you. Greatly appreciate your time. Thanks.
I'd like to thank the panelists for that fascinating exploration of the quantum.